Alright, so tonight we're going to be talking about circles, more specifically about the tangents of circles. So first, let's get some definitions out of the way. So a circle is a set of all points in a plane that are equidistant from the center. And we name it by drawing a circle with a dot in the center and then naming it by the letter of its center. So in this case, circle P. A chord is a segment whose endpoints are on the circle. A diameter is a chord that then contains the center. A secant is a line that intersects a circle at 2 points. And then a tangent, not like tangent like we did in trigonometry, different kind of tangent, is a line in the plane of a circle that intersects the circle at exactly 1 point. So here I drew a picture of a circle, and as we can see, the secant goes through the circle and touches at exactly 2 points, whereas the tangent only touches at point B. So here we have line AB that is tangent to my circle at the point of tangency B. So the point of tangency is where that single point that touches the circle is. Alright, so pause the video and look at the picture and see if you can name these 5 segments using the names we just did, plus some that you may remember from class. Alright, so the first one, A, was not on my list from earlier. I just defined AC, but everyone should know that that was a radius. AB was a diameter. AG was a chord. So AG is a chord because there's no arrows on the line above AG, so it's just a segment, so its endpoints are on the circle, so that's why it's a chord. DE is a tangent because it only touches at point B. And AE as a secant because it's a line that goes through the circle and touches at 2 points. Alright, so we're talking about coplanar circles, and they can intersect in different ways. So they can have 2 points of intersection when the 2 circles are overlapping. They can have 1 point of intersection, so those circles only touch at 1 single point. They could be inside each other, like the left picture, or they could be like touching each other in the right picture. And we call those tangent circles, just like we would say tangent lines, because they only touch at 1 point. And then the last ones, these have no points of intersection. And so these are circles that don't have anything to do with each other. They won't touch. Or you could have, like on the right, this bullseye. Those are called concentric circles because they all have the same center, just different radiuses. Alright, so here are some common tangents. So as we can see in the far left picture, that those 2 circles have 4 tangents in common, so 4 different lines that are tangent to each of my circles. Or we could have 3 common tangents, or we could just have 2 common tangents, depending on how the circles are situated. Alright, so next, Theorem 10.1. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at the radius's endpoints on the circle. So a tangent line is perpendicular to a radius. If it's not perpendicular, it's not tangent. So like this example, PT is a radius of circle P. Is ST a tangent of P? Well, to figure that out, we would have to know that angle T is a right angle. And if we remember way back from last semester, we could use Pythagorean theorem to figure out if the triangle was right or not. So we would set it up, c squared, and then we leave a blank, and then a squared plus b squared, because we don't know if c squared is going to be bigger or smaller or equal. If it's bigger, it's obtuse. If it's smaller, it's acute. If it's equal, then it's right. So if this is a radius, we want these 2 sides to be equal. So I plugged in my calculator. So 37 squared is 1369. 35 squared is 1225, and 12 squared is 144. So when I add 1225 plus 144, I find that it's 1369. So since 1369 equals 1369, that means that triangle PST is a right triangle, and therefore ST is tangent to circle P. Alright, let's try another one. So B is a point of tangency. Find the radius of P. So if B is a point of tangency, that means ABC is a right triangle. So I can use Pythagorean theorem to find my R. So AC squared is equal to AB squared plus BC squared. Well, AC, we don't have the full length. We have 50 plus that piece r. So 50 plus r squared is equal to 80 squared, which is my AB, plus BC r squared. So I know that if I have 50 plus r squared, that's the same as saying 50 plus r times 50 plus r. And then 80 squared is 6,400, and then we couldn't change r squared. When I FOIL, I find that on the left side of my equation, I have 2,500 plus 100r plus r squared is equal to 6,400 plus r squared. And if I notice, I have an r squared on both sides, so if I just subtract that, they will both cancel away, and I'm left with 2,500 plus 100r is equal to 6,400. When I subtract 2,500 from both sides, that means 100r is equal to 3,900, divide by 100, so my radius is 39 feet. Next, we're looking at Theorem 10.2. This theorem says that tangent segments from a common external point are congruent. So two lines tangent to the same circle that come from one endpoint are congruent. So let's use it in an example. RS is tangent to circle C at point S. RT is tangent to circle C at point T. Find the value of x. So since RT and RS are both tangent, and they both come from point R, then I know that RS and RT are equal. So I can say 3x plus 4 is equal to 28. If I subtract 4 from both sides, 3x is equal to 24, and so that means x equals 8. All right, so now let's talk about segment lengths in circles. So the first theorem we have is the segments of chords theorem. So you can use this theorem to determine lengths of chords. So if two chords in a circle intersect, then you can take the product of the two pieces of each one equal to each other. So if we look at my picture, EA and EB are going to be equal to EC times ED. So the product of the two pieces are equal to the product of the other two pieces. So for example, find ML and JK in this picture below. So I know using my segments of chords theorem that MN times LN is equal to KN times JN. So when I plug in my pieces, x times x plus 4 is equal to x plus 2 times x plus 1. So now on my left side I'm going to distribute, and then on my right side I'm going to FOIL. So I'm left with x squared plus 4x is equal to x squared plus x plus 2x plus 2. If I notice again on both sides I have an x squared, so if I subtract, those two will just cancel away. I'm left with 4x on the left side, and on the right side I have x and 2x, so I can combine like terms to say 4x is equal to 3x plus 2. If I subtract 3x from both sides, then x is just equal to 2. But that's not what they asked me for. They asked me to find ML and JK. Well, ML is equal to MN plus NL, so that's x plus... Sorry, I realized I mistyped on my slide. So first I'm actually calculating KJ. So KJ is x plus 2 plus x plus 1. But then we just found that x was 2, so that's 2 plus 2 plus 2 plus 1, and that is 7. And then to find ML, that's x plus 4, so that's 2 plus 2 plus 4, and that's equal to 8. And so those are our two answers, 7 and 8. All right, next I want to talk about secant segments. A secant segment is a segment containing a chord of a circle that has exactly one endpoint outside the circle. So one endpoint on the circle, one endpoint outside the circle. And then the external secant segment is the part of the secant that is outside of the circle. And so if you look on this picture below, in purple, I drew a curly Q over all of AB, so that whole piece is the secant segment. And then the portion AC, the portion that is not inside the circle, that's not part of the chord, that's my external secant segment. So we use these together in the segments of secants theorem using two different secants. And so what we're doing is multiplying the external times the whole secant secant is equal to the external times the whole other secant. So if we look at the picture, EA times EB is equal to EC times ED. All right, so let's look at this example. What is the value of x? So I'm going to do external times whole secant is equal to external times whole secant. So GH times FH is equal to JH times KH. When I put numbers in there, that's 3 times 7, because 3 plus 4 is 7, and then 2 times x plus 2, because we have to add the whole secant length. When I distribute and simplify, 21 is equal to 2x plus 4. Subtract 4, 17 is equal to 2x. When I divide by 2, x is equal to 8.5. All right, and next is the segments of secants theorem. So in this case, we have one segment secant and one tangent. So this should actually say secants and tangents theorem. So on here, and we don't have an external and a secant to multiply, and so we just do tangent squared is equal to external times whole secant. And in this next problem, I just want to remind you all about the quadratic formula. You should all know the Pop Goes the Weasel song to this. If you don't, YouTube is your friend. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now let's try a problem using my secants tangent theorem. So here we need to find RS. So again, we're going to do tangent squared is equal to external times whole secant. So that's going to be 16 squared is equal to my external piece, x, and then my secant is x plus 8. When I distribute, I get 256 is equal to x squared plus 8x. In this case, we can't just cancel away the x squareds like we have in the other problems because we only have one of them, which means we're going to need to solve our quadratic. So we have to have everything on one side. So I'm going to subtract the 256 to end with 0 is equal to 8 squared plus 8x minus 256. So we're going to use the quadratic formula on this. We know that our first coefficient in front of x squared is our a. In this case, it's 1. Our middle coefficient in front of x is b. In this case, it's 8. And then our constant is c. In this case, negative 256. So I'm going to take my quadratic equation and plug everything into it. So x is equal to negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 256 all over 2 times 1. When I simplify, my 8 squared becomes 64. My negative 4 times 1 times negative 256 becomes positive 1024. And then 2 times 1 was just 2. I simplify again, so negative 8 plus or minus the square root of 1088 over 2. I'm going to do a factor tree on 1088 so that I can simplify it down to negative 8 plus or minus 8 square roots of 17 over 2. So I'm going to divide both my pieces by 2, and I end up with x is equal to negative 4 plus or minus 4 square root of 17. And so that is the length of RS. And that is all I have for you tonight. See you later.